modern Western democracy, you could be forgiven for thinking that it's a system where you can think what you like and say what you like as long as nobody listens to you. It's this palpable frustration that we have of not being able to bring about change in our economic systems and our political systems or even our local communities that links up those who are on the fringe with those who are at the core of these systems. We're all feeling the same frustrations. So, yes, today I will be talking about the wonderful technology behind the 3D printers, but the story that you should take home is a story of how our cultural aspirations and probably more importantly our participatory aspirations that we've developed online are carving a path back into the real world. And as a part of this story, art and culture are really important. And art and culture are important because art and culture are about us, and we're the most important part of this story. Because if we take our responsibility as a citizen in a democracy seriously, then the 21st century won't be about the corporations or government. It'll be about how we, the citizens, built the world as we wanted it to be. So to start the story, I go down the path of the technology. So just talking about the 3D printers. Now, as an industry, 3D printing has been around for about 23 years, but we probably haven't heard about it for some time, unless, of course, you're an engineer or you're in manufacturing. Now, part of the reason of this is because it has, till recently, been quite an expensive thing to do. It also has been under patent protection, so it hasn't been open to everybody to be using. Also, our online environments have only in the last 5 years or so really developed the business models to make this something that we can all start playing with, so the crowdsourcing of ideas. The other reason is it comes under so many different names. There's personal manufacturing, there's 3D printing, there's additive manufacturing, there's some aspects of rapid prototyping, there's also e-manufacturing and a whole number of names that really mean the same thing or subsets of the same thing. Today I'll be using the term 3D printing. Now 3D printing uses things like this. This is kind of the entry-level machine, and this prints objects. It builds objects layer by layer, and that's based on 3D digital designs within the computer. And these, of course, can be uploaded, and they can be shared, and they can be printed out in machines like this. Now, industry, as I said, particularly manufacturing and engineering, have taken this, this technology and used it quite a lot. In the last 2010, 24% growth in revenue from this activity. But over the 23 years, it's been 26% growth year on year on year. And if you look at just the installations of these machines in the manufacturing industry, it's starting to get to that exponential growth in places like China. So this is going to be a big technology over the next 5-10 years. Now, industry has liked this because there's much less wastage because you're only laying down the material you'll need as you need it, pretty much. And also, you can get higher specifications on some of the more technically for engineering, technology sort of products. So if you think about aerospace, this is a printed item. You can print in steel, you can print in titanium, and there's also been used in the auto industry around 3D prototyping mainly, and that's sort of where they do build a prototype car. They use this technology, and also you're seeing things like the Boeing Dreamliner has actually used some of this. So it's starting to become a part of mainstream manufacturing. You may have also come across it in terms of dentistry, where scans can be printed, and then also the tooth caps can be printed in different materials. You may, if unfortunate enough, you needed a prosthetic knee, which this has been printed as well. So the sort of steel, plastic, but also ceramics, glass, and the different materials that can be printed in grow every year. And this technology has changed rapidly, and as we speak, it is just developing incredibly quickly. It's also, of course, being used in much more creative industries. So, say in architecture, where a digital 3D model can be printed out into a real-world 3D model. And as you can see, quite a bit of detail as well. And it's used in the arts. And I think this one demonstrates quite nicely how you can actually print all the moving parts. There's no assembly. You don't print the parts separately and assemble. You print the whole thing, all the moving parts, all at the same time. And also you can have quite detailed 3D scans or just a lovely art product or a lovely object. And these are available for you to print now, and you can also upload your own designs and share them with people as well. And some people are making small businesses out of this. So that's great. We can do this wonderful type of manufacturing, but why is it so important? Why is it such a big change that we're going to be going through? Well, if you think about open source prosthetics as one area where people have been applying 3D manufacturing, there's a lot of open source prosthetics projects, but when it comes to 3D manufacturing, the idea is that you can have a open source generic model on a computer, but if you went to a remote place that required this type of prosthetic, maybe somewhere that's been a war zone for many years, you could come in with a manufacturing machine, a laptop, and a 3D scanner. And just this week, the appropriate 3D scanner has been released as an app for your smartphone. So basically, a smartphone, a laptop, and one of these printers, you could go in, scan the patient in the area, and then you could match that with the open source design work to custom make prosthetics for people, and you print them out as you require them. Now, once again, how come this is different manufacturing? Well, when we think of manufacturing, we normally think of these guys. We normally think of little plastic men in suits. Well, not often plastic, but unfortunately mostly men. And they tend to run these things, really big factories. And you have tens of thousands of people potentially working in these factories. And we've already known since the Model T Ford that if you undertake mass production, you can get products out that are relatively reasonably priced, and the things that you sacrifice, though, is they're reasonably generic, and it takes a lot of resources. So if you want to do a manufacturing run of cars, and you're talking about 100,000 cars, that's a lot of investment up front to make that happen, and therefore you need people, the plastic men in suits, to be making those decisions for you about where those resources are going to be put. 3D manufacturing is different because you get rid of the plastic men in suits. Sorry, plastic men in suits. The 3D printing is really about us because you can have all the designs online. They don't actually have to come to fruition until somebody actually wants one. You don't have to store surplus. You don't have to have the storage there. You, in terms of the transportation or shipping of goods, you don't require that. So you're taking out that barrier between the person who might be a consumer, but they might be a creator, and also the industrial processes. So we're actually getting to a point where industrial manufacturing processes are much more about us and what we want to create. And also it's about customization. It doesn't cost any more to customize, whereas we can get completely rid of this mass production idea. And the other thing is it is networked. And we can move away from this really large centralised factory idea to this idea of having shopfront factories, or factories in your own home for that matter, where you can source a design from anywhere in the world, you can get it printed out at your local shop, and you can go down and you can pick it up. So as we know about the effect of manufacturing through globalisation, this completely changes how that works. Now, if you hook this up with open source technologies, such as open source engineering, or open source electronics, you start seeing that you can develop quite complex pieces of machinery and gadgetry. And while it's still a few years off, they're starting to see that you can print the printed circuits. So it's not out of the question that in 10 years' time, you would actually be printing out the entire gadget in one go. But once again, this is fantastic, but how does it relate to arts and culture? Well, it starts relating to arts and culture in so much as it's about us, and we're taking away those barriers, so we don't need to be mediated through that management or mediated through large investment. So to talk about this properly, though, I have to use the dreaded I word. And in this case, the I word is innovation. And a few people, there was a few groans there. A few geeky people in the audience will be very, very happy because they love thinking about innovation. And need to go through this because we think about innovation often incorrectly, but also we hardly ever think about it in terms of arts and culture. So innovation is often thought about as something new or novel. And I work in the arts, so that's pretty much how it's thought about. But that's only really part of an idea of innovation. Innovation is much more about applying those ideas to people and how you apply those ideas to people, and also applying those ideas to people for benefit. Now, when I started working in the arts, I started working in a fantastic place where we bring arts and culture together with technology and science, which is kind of a bit of a different subset for the arts. And what I really noticed when I started seeing artists involved in pure scientific research was this, something really interesting happened. If you think of a continuum with invention down one end and innovation down the other, artists often sit down at this end where it's, you produce a beautiful object, the invention end. And pure science is often around that invention end. If you start getting the innovation end, you're applying those ideas to people. And often that comes out as the two market area, but also it is just when those ideas become how we think. When I saw artists working in these environments, they were immediately sort of thinking about the science and also technology research about how does this apply to me, my family, my community. So as soon as you start applying these ideas to people, you have an innovation process. And culture is really this idea about how we take on these ideas that have been created and they become a part of our life. So culture is really a process of innovation where we're applying ideas to our daily lives. And you can think of art in this context as the research and development driver of culture. And I'll show you what I mean by this idea of digital folk art. So digital folk art is this idea that we are now creatively communicating online. We produce crappy videos on YouTube. We do wonderful 8-bit fan art. We comment on things, we share photos. Now, in the arts, often people don't think much of this activity, but in actual fact, the arts should be incredibly proud that we can share crappy videos on YouTube. Because the arts often did much of the thinking of how you communicate in this way. They even had a hand in developing some of the methods and technologies of how you go about doing this. And what the arts do is they explore these ideas and they become some of the tools and the language that we use more broadly in our culture. So there's this intimate relationship between the two. So if you start thinking of art as R&D and you start thinking of culture as an innovation process, how does this link through to what we would traditionally call business or the economy? Well, I use this idea of the evil robot paradox. Now, the evil robot paradox goes like this. Building a robot is a technical problem, but living with one is a cultural problem. So this is the idea that as technology moves beyond being a tool, but becomes an augmentation of us, it becomes a part of how we see us. It has to be deeply culturally sympathetic, because if it isn't, I don't want it anywhere near me. So we can spend as much time as we like doing the research and building robots, for instance, but if we can't live with them or they're not culturally sympathetic with us, then we won't want to have a bar of it. The other aspect of this is that if you're going to be constructing robots that are culturally sympathetic, then you might have robots or technology that needs to be predictably irrational, just like us. And the sense that we get a lot of good things out of people who may not be particularly nice, we might be getting better results out of technology that has particularly unsavoury behaviour, and you may end up with an evil robot. So if you see this idea where, once again, art is the R&D, culture is the innovation process, and there's a growing need in industry and business to be producing things that are really culturally sympathetic, then you start seeing that what's required in business, or what's required to change how we go about manufacturing, it really that link comes through 3D printing. Because what 3D printing is doing is taking away that distance between us and our capacity then to change what we're doing culturally into a manufactured process. And really we're talking about what we require in industry is creativity. Now, business often has trouble with creativity, of truly harnessing creativity in a way that doesn't destroy the reason why people want to be creative. There's a whole intrinsic motivation within creating an artwork that can be destroyed in those business contexts. On the other side, though, if we're starting to see the capacity for creativity, culture to be driving industrial processes, then definitely in the arts, there's not the role in terms of the economy or industrial process isn't taken seriously enough. And there needs to be a drawing together of these two ways of working. So to do this, where I work, we think of transdisciplinary, which is a lovely big word, but what it's really doing is, if you look at have the idea of neurons, it's about plugging in all this different data. And if you plug in all this different information and it links to other nodes, then you can get quite sophisticated behaviour coming out, such as consciousness. And if we're thinking about the problems that we face and trying to resolve these problems, because both from a community perspective and a business perspective, resolving problems is a good thing, then if you start mapping the complexity of the world with the complexity of the people that you're working with, the difference that you're bringing together onto one project, then you start being able to resolve a problem without even having to have that end goal in sight. You don't need to know how to resolve the problem. It's actually working through the problem collectively that helps resolve it. So to build the world as we want it to be, what we need to do is we need to cross over to people who we don't normally work with. So in my case, I see a huge benefit from science and technology working with the arts, but also there's a huge benefit for the arts working with business. And it's finding out those people who you would probably never work with a million years and actually sitting down and starting to work with them where you start getting the real benefit out of it. And our allies in building a world are those creative people. So it's good to seek out the scientists, it's good to seek out the artists, it's even good to seek out the entrepreneurs if you're coming at it from a business angle. These are the people who will help bring those disparate ideas and join them together into something new. So to build the world is really more about collaboration than technology. But in this case, I think the technology is actually removing a step as opposed to really empowering us to do something. The power is with us anyway, and the technology is merely getting rid of the roadblocks that we have from working together. Thank you.